BDR will be demonstrating the JSONization and advancements and enhancements of HL7 while it's completing, and we're shooting for the end of this year 2021 to be able to have scalable, high volume, quick ingestion into FHIR. For without us getting this done, we feel FHIR will not be widely accepted for several years yet to come, because companies have only gotten small amounts of the resources in the fields. So there's a lot of important health care information for patients and providers that they anticipated having that they don't, and to meet ONC compliancy to allow patients to get to their billing and other health data and securely download it. So what we have done is taken the HL7 JSONization and capabilities of going to multiple databases, working with Snowflake and S3 and Redshift and all the RDBMSs and so on. So these capabilities will allow extensive reporting and capabilities for patients, for healthcare providers, for analysts, for marketing folks, to do the things they thought they were going to do from FHIR, and to extend in HL7 what HL7 has been stifled from being able to do. So with that said, I'm going to move on and show you us JSONizing data, moving it to different RDBMSs and to big data, reporting on it, downloading it, and migrating it. Thank you. Now, as we move on to the presentation, we're looking at the HDFS representation of raw HL7 data. We're then going to take this raw HL7 data with repairs if it needed, and we are going to migrate it and JSONize it. We can send it to many places, as we just saw on the list, and we're going to migrate this into Snowflake at this time. So we're in the Snowflake interface, we're giving it a table name, and we're going to run the process to take that raw HL7, and we are going to then write that and migrate it encrypted. As you see, it's not in Snowflake at this time. So once the job completes, the job just completed, we are now going to go back into Snowflake and we'll refresh the schema, and we now see the HL7 JSON convert, and we see that the data has been JSONized and it has also been AES 256 encrypted. So now that we've done that, we're going to show how we could take that migrated data from wherever it would have gone, in this case it's Snowflake, and we're going to create a report. Now we're showing all the message types, fields, and we're selecting them. But sometimes people are used to EMR and EHR names that are different. So we allow the users, the analysts, and people to come in, and they can put in their own description. So when they add the description metadata to one or many columns, and if you notice the columns and messages are sorted, now when they move the mouse over the field, they'll see the name they're used to. So other people that aren't used to these names or the FHIR names will be able to find the information they're looking for. So now we're running and generating a report. Now that the report has finished, we're going to, and that report is stalled encrypted, but we can read it on the screen. There you can see first name, last name, but the others won't have bubble up help. And we can see that we got the information we asked for in the report, with the segment names and the column names and types and so on. So now we're going to say we want to download. We create an encryption key to securely do a download with HTTPS, SSL, Crypto.js, and others. and it'll be encrypted end-to-end until it hits the device, the iPhone or the device it's going to, and there we can see the CSV file, and there's the report that we requested. So now that we see how to create a report, we also will now show how to migrate or download this report to another database type. But we also want to show here in Snowflake that the data is still encrypted. We never decrypt that system source of record. We keep that security. Now we're going to report to a database. Now we're going to report to BigQuery from Snowflake into an existing, but we want to show you we could have gone to MySQL, DB2, Oracle, Postgres, SQL Server, Teradata, or Snowflake. So we're going to pick Google's BigQuery. So now we've got the configuration pre-configured. We're going to now add a table name, HL7 report generate. We're going to execute this, but our Spark capabilities allow us to adjust memory clusters, types, executors to make things run quicker and scale depending on how much data is expected to run through the process. It can be IoT, it can be data at rest. So now we're going to go look into BigQuery, and we're going to refresh, and we're going to find the migrated table that we just created, which better be encrypted. So there's the HL7 report generate table. Where he refreshed it, we're going to open it up, we're going to view it, and the schemas are auto created, and there's the data that's encrypted. But now people say, what good is encrypted data going to do me? Well, BDR has APIs and proxies to take care of that. So you can just click on an icon and we can decrypt that data. So that's what we're doing, and we're going to show you that the data is decrypted. If you needed to for certain purposes, for certain time frames, based on security, maybe you went off the grid, offline, so the risk was minimized, or maybe no risk. There it is. Now it's decrypted. Now we're done with that, so we want to re-encrypt it. That's our responsibility. We want to make sure that data is encrypted when it should be encrypted. So now we're running an encryption process, and that's going to go back into the BigQuery data, and we're going to refresh it. We're showing you there's the decrypted data. Now the refresh has taken place, and shortly we will see the refreshed data. And once again, so I don't get mud in my mouth, we should be seeing encrypted data, and there we have it. The data is once again encrypted. Just want to show the amount of tables and big data that we can write to, and we can migrate is pretty extensive. HDFS, Redshift, S3, Snowflake, BDR Warehouse, BigQuery, and MongoDB. BDR Warehouse is PostgreSQL SQL. We built our own little warehouse capabilities. So there you have capabilities of HL7, much farther beyond where HL7 was able to go in the past so easily, with a nice UI graphical interface, source and target capabilities, mixing RDBMSs along with big data, data lakes, and the latest, and everything is written in Spark, Spring, Boot, Hibernate, which is fully 100% compatible with FHIR, which is our ultimate goal. Our ultimate goal is to get everything successfully running in FHIR, and we are working hopefully by the end of the year to have an ingestion process completely done. In the meanwhile, you can meet CCPA, GDPR, HIPAA, and ONC to allow patients to download their data. I thank you again and hope to see you at our next upcoming video, which will be out shortly. Again, thank you.